Ever wondered how a normal pair of glasses can walk outside with you and suddenly turn into sunglasses? At first, it feels almost like magic. You step into sunlight, and within moments, the lenses slowly become darker. Then you walk back indoors, and they become clear again. Today on Knowledge Hub, we are looking at how photochromic glasses, often called transition lenses, turn dark in sunlight. The secret is hidden inside the lens material itself. These lenses contain special photochromic molecules. The word photochromic basically means light-changing color. Indoors, these molecules stay in a clear form. In that state, they allow most visible light to pass through, so the lens looks almost like a normal clear prescription lens. But the moment you walk outside, sunlight brings something powerful with it: ultraviolet light, or UV. UV light has more energy than the visible light our eyes can see. When UV photons hit the photochromic molecules inside or on the surface of the lens, they give those molecules enough energy to change shape. In many modern plastic lenses, molecules such as naphthopurines or spiroxazines can switch into a different molecular structure. Think of it like a tiny folded shape opening up. Once the molecule changes shape, the way its electrons move also changes. The molecule starts absorbing more visible light instead of letting it all pass through. And when millions and millions of these molecules do this at the same time, the entire lens appears darker. So the lens is not producing darkness, it is absorbing more of the light that would have reached your eyes. That is why your eyes feel more comfortable in bright sunlight. The stronger the UV exposure, the more molecules switch into their darkened state, and the darker the lens becomes. This is also why photochromic glasses usually do not darken much under normal indoor lights. Most indoor lighting does not contain enough UV energy to trigger the same reaction. Now, older photochromic glass lenses worked a little differently. They used tiny silver-halide crystals, similar in principle to the chemistry once used in photographic film. When UV light hit those crystals, silver ions could turn into tiny silver particles, making the glass look darker. When the UV disappeared, the reaction reversed, and the lens became clear again. But most modern lightweight plastic lenses use organic photochromic dyes because they work better with today's thin, light, impact-resistant lens materials. Here is the clever part. The process is reversible. When you step back indoors or move into shade, the UV trigger disappears. Without that UV energy, the photochromic molecules slowly return to their original clear structure. As they return, they stop absorbing as much visible light, and the lens becomes transparent again. This is why the darkening can feel faster than the clearing. Going dark is driven by sunlight hitting the molecules, but clearing depends on the molecules relaxing back, which can take longer. Temperature also matters. On colder days, photochromic lenses can often become darker and may take longer to clear, because the molecules move more slowly when cold. On very hot days, they may not reach the same deep darkness, because heat helps push the molecules back toward their clear state. That is why the same pair of glasses may behave slightly differently in winter and summer. Another interesting thing is what happens inside a car. Many people expect their lenses to turn fully dark while driving, but they often do not. That is because most modern car windshields block a large amount of UV light. Since standard photochromic lenses need UV to activate, they may stay much lighter behind the windshield, even when the visible sunlight outside looks bright. Some special driving-focused photochromic lenses are designed to react more to visible light as well, but regular ones mostly depend on UV. Modern photochromic lenses are also carefully engineered to look natural. A single photochromic dye might create an odd color, so manufacturers combine different molecules that absorb different parts of the visible spectrum. This helps produce a more balanced gray, brown, or green tint. On top of that, the lens can include anti-reflective coatings, scratch-resistant layers, blue light filtering, and UV protection. But the darkening itself still comes down to one beautiful idea. Light changes molecules. Molecules change how much light passes through, and your glasses adapt to the environment. So the next time your glasses turn dark the moment you walk into sunlight, remember, there is no battery, no hidden chip, and no tiny sensor inside. It is a reversible chemical reaction happening millions of times across the lens, using ultraviolet light as the switch. If you've enjoyed this deep dive, don't forget to subscribe to Knowledge Hub for more fascinating explanations of the technology and science behind everyday things. And as always, stay curious.